Let us discuss about the concept of conjugate hyperbola. The standard parabola is given by x square by a square minus y square by b square equals to 1. This hyperbola, it looks like this. This distance here is called the transverse axis and is equal to 2a, and we have two more points on the y-axis which we mark as b and b dash, and they are called the conjugate axis. And here we have a and a dash. Now, what we want to do is we want to form another hyperbola such that the y-axis becomes the transverse axis and the x-axis becomes the conjugate axis. Now, in order to do that, let me write another equation in the following format. X square by a square minus y square by b square equals to minus 1. So what we have done is 1 is basically replaced by minus 1. And if we rewrite this equation, we obtain y square by b square minus x square by a square is equals to 1. And if we now want to draw this new hyperbola, its diagram would look somewhat in the following manner. And now the transverse axis of this hyperbola is of length 2b and the conjugate axis is now equal to 2a. So this new hyperbola is in a manner that the conjugate and transverse axis of 1 is now equal to the transverse and conjugate axis of the other. Then such a hyperbola is called conjugate hyperbola. So if this standard hyperbola is represented by a letter H, the conjugate is represented by C. So this is a very important result which we must try to remember. Now, if we want to discuss in detail about the properties of the conjugate hyperbola, then let us talk about the center of conjugate hyperbola. It will be equal to the same as the center of the original hyperbola, that is 0, 0. The length of transverse axis is equal to 2b. The length of conjugate axis is equal to 2a. Next is eccentricity. The eccentricity of conjugate hyperbola is given by under root of 1 plus a squared by b squared. So if we want to rearrange this equation, we get e squared minus 1 is equals to a square by b square, or we can also write a square as b square into e squared minus 1. So this is the formula for eccentricity. The foci is given by 0, plus minus b into e. The equation of directrix is given by y is equals to plus minus b over e. So basically, as you can notice, that the role of A is now being played by the letter B and the role of B is now being played by the letter A. Next is the length of lattice rectum. So lattice rectum is now equal to 2A squared by B, and the parametric coordinates of conjugate is given by A tan theta comma B sec theta. And next is the focal distance, and that is equal to EY1 plus or minus B, or let me write YP, where P denotes the point whose focal distance we want to find. Now then we can also write the difference of focal distances is equals to 2B. So that is all that we have related to conjugate hyperbola. So we now understand if we have a hyperbola, how we can find its conjugate. There are two ways to write down the equation of conjugate. So what we can do is we can make y square upon b square as the first term. This is one way of writing the conjugate hyperbola. Or in the standard form, if we just replace 1 by minus 1, we get the equation of conjugate hyperbola. Now this is a very important video, students, because here we have discussed about various important points and other important results. So you must try to always keep these results in mind, and that is all that we have in this video, students.